Okay, first, the superposition of longitudinal waves. Already, I think if you can recollect, we had a discussion about the superposition phenomena. If two waves undergo superposition, then the resultant displacement is given by y is equal to y1 plus y2. So let me say that superposition of the same idea we are going to construct. Two waves are there, they undergo superposition. Then what is the displacement at a given point at a given instant of time? That is given by the algebraic sum of the resultant displacement at a point is equal to algebraic sum of displacement of a point individually due to each wave. First, I'll measure only due to wave 1. Then I'll measure only due to wave 2. Then I'll take superposition, I'll get the resultant displacement. This is what we discussed here. No? So suppose two traveling waves are there. So first, we'll begin like this. Let y1 be equal to a sine omega t kx. So a is equal to sine omega t minus kx plus it will have some phase angle theta. Let me write. These two waves undergo superposition. Then the resultant displacement at a given point is given by y1 plus y2. Okay, I agree this. So there's a thing. So like this, what happened? We can use the same earlier superposition principle. Okay, now what happened? Specifically, what are y1, y2? Traveling sound wave. TW, I'm writing in short, traveling sound wave. Now you can ask questions, sir. What is this phase? Why it is having phase? Maybe this will cover more distance than this one. Because if a wave covers according to the concept, I'm just covering, I'm explaining background of so that I can straight away jump into the topic interference. So now if a wave moves a distance lambda, tell me how much of phase it will gain? Pi radian, 2 pi radian. If a wave moves a wave moves distance means it will propagate, it will move. So as it propagates a distance means the wave is here, the wave is here. And after some time it is here. So it has covered a distance how much? Lambda. Tell me how much of phase? Initially it was 0 phase. So now how much of phase will be? 2 pi. We'll agree this. And, and suppose say if a wave is here, and if a wave covers a distance of say lambda by 2, how much of phase it will get? So I'll put select a delta x. So what is delta x? Delta x is this one. Path length or distance covered by the wave. So how much the wave has moved? So it was here. Then it has covered a distance of lambda. Then how much of phase it has gained? 2 pi radian. So how do you can say this particular formula here? Now similarly, if a wave moves a distance lambda by 2, how much of phase it will gain? It was having 0 phase. So it will gain some phase. Means sir, like a, will it be like this? The way you are telling 2 pi will be like this. The phi will be, in fact, I have to show like this. Will I agree? Why this changes? Because it should have a phase of pi radian. Able to understand this. This is the more, you can say the concrete idea of the wave propagates. As it propagates, what happens? The phase of a wave changes. The phase of a wave changes. So I'll put it in nutshell. The phase of a wave, or the wave gains phase the wave gains phase as it propagates. So if it propagates a distance, if it covers a distance of lambda, how much of phase it will gain? 2 pi. This is the formula. If a wave propagates a distance of lambda by 2, then how much of phase it will gain? Pi radian. So are you looking at this one? Similarly, sir, the wave will propagate lambda by 4. Okay, then pi by 2. pi by 2 means what happened? It'll become cos like that. So in this way, why this having more phase? Definitely at a given point, this has covered more path than this particular thing. No, if such a two waves undergo superposition, means I will directly get into the topic here. No, so there are two sources are there, S1 and S2. Let me choose a point P where like a initial phase of them, let it be 0. Both are generated with a 0 phase. Okay, you can see the from the diagram here. Now you take like this. So let this distance be 3 meter. This is a 4 meter. Then how much of path length this will cover? So I'm using word path length. What do you mean by that? Distance covered by the wave. So what is the term? The distance covered by the wave. Wave. The distance covered by the wave is called as path length. Are you getting the idea? Distance covered by a wave is called as a path length. So I'll be using, there's a technical, what is the path length of the wave? Means how much of distance it has covered or how much of distance it has propagated. Please do get familiar with the words first. Means I'll generate two sound waves. So now I'll call these two sources as coherent. Okay, first of all, what do you mean by coherent? S1, S2 are coherent sources, I'm saying. Now the first word coherent, C-O-E. Okay, I'll rewrite. Coherent word. Sir, what do you mean by coherent? That one. Two sources of same frequency and the phase difference between them remains constant with the time, they're said to be coherent. There's a basic definition. We'll define that coherent here. Coherent sources. Two sources of same frequency with phase difference remaining constant with the time. With the phase difference between them remaining constant with the time are said to be coherent here. So next, what about incoherent? Incoherent sources. So what about them? Two sources of same frequency with phase difference varying with the time, phase difference varying with the time, or two sources of different frequencies. So like this, what happened? We will say coherent and incoherent. So now what I considered is two coherent sources which are separated by certain distance. S1 and S2 are coherent here. So like we are not understanding something you are saying phase difference. What actually meaning of this? Can you explain that still more clearly? This will be the typical question. Okay, let me introduce some. Okay, I'll do one thing. I'll push this to the next part in the discussion. Just wait, let me adjust it. Yeah, let's compose it. So let me show what do you mean by coherent and incoherent. So let me have graphically, I'll represent like this. This is the source one. I think look at both are having same frequency. So this is the source S1, S2. What is this? Y-axis is the amplitude and x-axis is time period. Y of t graph of two sources, wave generated. So definitely these two are what? Coherent. So what do you mean by that one? So you look at the time period. Look at the time period. Time taken to complete one oscillation is same, no? Both are having same time period. You can see from graph. One more curve. Look at, see this one. This is the S1 and S2. So now I can say they are coherent. Sir, okay, fine. Both are having same frequency. Okay, now look at the time period. So both are having same time period. What do you mean by time period? Time taken to complete one oscillation. All of you, I think by this time you are in far better position. If I say time period, you know it. So or else I'll shade it. Look at the time period. Yes, both are having same time period. Okay, this is their side. And look at the phase also. One more condition. Phase difference remaining constant with the time. What was the phase of this? 0. What is the phase of this? 0. And at this instant of time, t by 4, what is the phase of this? Pi by 2. This also pi by 2. At t equal to t by 2, capital T by 2. What is the phase of this pi? This phase. So at any instant of time, come and check what is the phase. Will remain constant with the time. And how much it is? 0. Are you getting the idea? This one. So now I can say that these two waves are coherent. These two waves are coherent. It can happen like this also. It can happen. I think I'll draw a little bit small. Amplitude doesn't matter. Only one line. No? Okay, this is the one wave. The other wave, I think I'm, yeah. Of waves, I'll draw it. Okay, now this is the wave generated by source S1, this is S2. Look at what is one time period, this is a one time period. Again, are they are of same frequency? Both are S1, S2 are same. Both will take same one time period to complete one oscillation. You can see this. Getting the idea? Now, what about the phase? What was the phase of this zero? Okay, I agree this. Phase of this is how much? Zero. What is the phase of this? 90 degree, no? So this is, what is the phase difference? So let's say 90. When this becomes 90 degree, what is the phase of this? This will be zero. So look at the phase difference. The phase difference between them remains constant. At all the time, it will be, magnitude will be 90 degrees. So therefore, are they coherent? Yes, both are having same frequency, but the phase difference between them remains constant with the time. So still they are said to be coherent. This is an example of coherent sources. Okay, now I'll bring incoherent. How do that incoherent? See, these are very important, not mere definitions. In books, you have definitions. Yes, okay, fine. You are gathering information, but really what do you mean by coherent incoherent means a student has to imagine a diagram of like this. So this is a wave of some frequency. It is generated by the, so this one. Another wave, this is due to source S1, source S2. Can you say anything about anybody? What is the time period? This is the one time period, T1. What is the time period of this? This is only T2. Are they same both? No, they're different, no, totally. This is what you say. What is the time period for this? The time period for this will be only this much. Look at T1, earlier time period was same. Here T1 not equal to T2. F1 not equal to F2. Are they coherent or incoherent? They will be incoherent, finish all. And look at the phase. There's no any exact relationship, no? Like the phase difference is varying with the time, so therefore they're coherent. Sorry, they're incoherent. Got the idea now? This is one basic overall thorough picture about the two sources, coherent and incoherent. Anybody having doubt, you can clarify it, because I'll start the concept, I'll end up. Because the background is what we needed, only this much here. Varying with the time, or two sources of different frequencies. They will be incoherent.